Hello students, in today's video lecture of engineering drawing, we will discuss projection of lines. In the previous lecture of projection of points, we have learned the concept of projections in all the four quadrants. When a point is placed, how the orientation is going to be, how the positions are going to be placed on a laid drawing sheet. Okay, now today's lecture is projection of lines. Fine. Now before going into projection of lines, let us see what is first angle projection, what is third angle projection. We will try to concentrate on these two, because whenever a question is given, there are two things need to be known. He may specify in the question, he may not. Okay, if he specify in the question, you have to follow that particular projection only. For example, for first angle projection, third angle projection, we need to know the basic difference between first angle and third angle, which is very much important. Few times it may be specified in the questions, few times it may not be. Okay, if you have specified third angle, means you have to follow third angle projection only. If you have mentioned first angle, means you have to follow first angle only. If nothing is specified in the question, you need to follow first angle projection. Fine. Now for a basic understanding, I'll take a simple 3D model. Let us consider a cone. Most of you are familiar with. I'll consider a cone, okay, which is having an apex point and a circular base with some height, infinite distance height. Fine. Now I'll try to cut the cone from the top apex point at some offset distance. I'll try to cut the cone. I'll try to remove this portion, and this portion will remain. Once I remove the sharp corner from the top, how it look like? The component may look something like this. So we call this as frustum of a cone. Fine. Now this frustum of a cone will help you to know better about first angle and third angle projections. Try to concentrate. I'm trying to position the frustum in this way. This is the front view position of the frustum. Now here the diameter is less compared to this diameter. Let us consider this as 10 mm. This may be 15 mm. Fine. If I draw the side view, if I view from here, the position of the observer is here, then I could see a smaller circle as well as the bigger circle. Fine. So the position or the side view is going to be something like this. I could see circles. Fine. Both are visible. Similarly, if I view from right side, then what happens? Only the bigger circle diameter is visible, smaller circle diameter becomes invisible. So when I view from here, whatever is visible, I'm going to draw towards right side, to the opposite side of the observer. Means that is nothing but first angle projection. Whatever I'm viewing from left, whatever is visible from left, I'm going to draw opposite to the position. Okay, exactly opposite to that particular position, or else exactly to the right of front view. If I call this as front view, to the right of front view, I'm going to draw the projection, whatever is visible from the left. Whatever is visible from the left, I'm going to draw towards right side. Similarly, whatever is visible from the right, I'm going to draw towards left side. Okay. So here when I draw what I could see a bigger circle concentrically, this becomes invisible. Smaller circle becomes invisible. This is the position. Fine. This is how we'll draw in case of first angle projection. Whereas in case of third angle projection, what happens? Same frustum, I'll position something like this. Bigger diameter, smaller diameter. If the position of the observer is here, again what is visible? Both the circles are visible. Whatever is visible, you are going to draw in the same side. Smaller circle and a bigger circle, both are visible. Similarly, if I view from here, whatever is visible from right, same thing I'm going to draw right. A bigger circle is visible, smaller circle is invisible. Now have a look at the difference. What is the difference between these two? It is completely reverse of first angle projection. Same thing we have seen in projection of points also. So knowing about first angle projection, third angle projection is also very much important. When it comes to first angle projection, right side view going to be left side view going to be right of front view. Similarly, in case of third angle projection, right side view will remain right, left side view will remain left. Fine. Now again, first angle projection nothing but we are dealing with first quadrant. Third angle projection we are dealing with third quadrant. Okay. That is the difference. Now let us talk about lines. Fine. Let us consider for this session of video lecture, we'll consider a line AB, I'll name it as AB, of 80 mm length. A line AB of 80 mm length. Okay. Now how you define line is nothing but the shortest distance between 2 points. Okay. It is a linear member. Fine. We can call it as a linear member. with respect to x and y quadrants, there is a line something like this, linear member. So we call this as a line, the shortest distance between 2 points A and B is nothing but a line. Okay, if there is a curve of this kind which is a non-linear one, when again having two endpoints, will never be called as a line. Okay, this is called as a curve, which is a non-linear one. Line is always a linear member. Fine. Let us consider this object. Name of the object is AB. Let us call it as AB, having a length of 80 mm. Now we'll see the positions. We'll see different positions of this particular line in case of first quadrant. Okay. Now position of a straight line, I'll write it in a short form. Position of a straight line, first quadrant. Okay. Now first quadrant, nothing but you have horizontal plane, you'll be having a vertical plane. Based on this horizontal and vertical plane, we'll try to imagine a line. Okay. Now for your better understanding, for your convenience, I'll use a piece of card as a horizontal and vertical plane. Let us imagine for this session, this as the horizontal plane, this as the vertical plane. Okay. Now these two will always remain 90 degrees to each other. The way we have discussed in projection of points, when some object is here, some x object is placed here, let us say point A. When I view from the front, this is the front view position. When I view from the front, the projection of this going to be on vertical plane. Similarly, when the position changes from front to top view, position of the observer changes from front to top view, what happens? I can view the object from the top. The same object's projection going to be on horizontal plane. Now what is the basic concept that we have discussed already in the previous lecture of points? The horizontal plane always going to rotate 90 degrees clockwise. Okay, if this rotates 90 degrees clockwise, what happens? This will go and align with a vertical plane completely. Then what happens? The projection which is already there on the horizontal plane going to match up with vertical. Fine. So the projection going to be on vertical again. So both the projections, front projection and top projection, both will fall on a single straight vertical. That is the same thing we are going to draw on a drawing sheet. Same thing we are going to draw on a drawing sheet. Simple thing. Fine. When both the planes are 90 degrees to each other or perpendicular to each other, this can't be drawn on a plain drawing sheet, which is impossible because drawing sheet is completely laid on the table. Fine. That is the reason we are rotating horizontal always 90 degrees clockwise. Whether it is a point, line, plane, that is going to rotate below the XY line. Let us consider this dark black line as XY, X and Y end. This is horizontal plane, vertical plane. Okay. Now let us see the probability, like how many ways we can place a line AB 80 mm in this particular quadrant number 1. Let us imagine this as a line AB of 80 mm length. Fine. This as a line AB of 80 mm length. Fine. Now let us consider this end, green color one, this end as A, this end as B, A and B. Fine. Now whenever a line is placed something like this, for example, this line is perpendicular to HP, parallel to VP. The line AB 80 mm is perpendicular to HP, parallel to VP. Fine. Now the line may be at a distance of 10 mm above the HP and some 20 mm in front of the VP, or else 10 mm above, 10 mm in front. Okay. Or else the line may be on the HP, the line may be on the VP. The conditions may be many ways. Okay. This is the position, orientation of the line AB of 80 mm length. Okay. Perpendicular to HP, parallel to VP. This is one assumption. Fine. Similarly, it is the line perpendicular to VP, parallel to HP. This is the position. Okay. Perpendicular to VP, parallel to HP. There might be some above distance and infrared distances also. That we'll see when we solve a problem. Okay. Now when the same line is placed something like this, you could see true shape from front view as well as the top view. So line is parallel to HP, parallel to VP. Fine. This is one more condition. Remember, this is going to be your front view. Always 90 degrees or normal to the vertical plane is your front view. This is your top view. Fine. If that is the case, from the front you could see that the true shape going to fall on vertical plane. True shape going to fall on vertical plane. Similarly, if this is the case, From the front, I can't see the true shape. I could see only a point, which is A. When I view from the top, I could see the true length or true shape of line AB, which is falling on horizontal plane. As we rotate horizontal 90 degrees clockwise, what happens? The line will completely come below the XY line. Now, whatever the distance is given in the question, accordingly. Now, when the same line is parallel to both, what happens? You could see true shape from front as well as from the top. Same thing. This is going to fall, front view falling on VP and top view falling on H. HP will rotate clockwise 90 degrees always. So, it will come below the XY line. These are the conditions. Other than this, you could see same line is inclined to HP. It is making some inclination. It is not perpendicular exactly. It is making some inclination, which is inclined to HP, maybe 30 degrees, 40 degrees, whatever given in the question. Inclined to HP, parallel to VP again. Inclined and parallel to VP. When it is perpendicular, also it is parallel to VP. Similarly, it is inclined and parallel to VP. If the same line is inclined to VP, it is parallel to HP. Try to make some thumb rules. Like whenever a line is perpendicular to some plane, it is quite obvious that it is going to be parallel to the other plane. Fine. If it is perpendicular to HP, it is going to maintain parallelism with VP. If it is perpendicular to VP, going to maintain parallelism with HP. If it is inclined to HP, it is going to parallel with VP. If it is inclined to VP, going to be parallel with HP line, HP plane. Fine. Now in this case, both it is parallel to both the planes. And one more condition is there, which is a line inclined to both the planes. The position may be something like this. In projection of lines, line inclined to both the planes is one of the condition which is somewhat tough to understand. This is the only, we'll see at the end of the session or end of the projection lines, or else I'll take a separate video lecture to make you understand when a line is inclined to both the planes, how the projections are going to be. Okay, which is very much important in case of your external as well as in case of your internal examinations. Okay, now let us start with the basic conditions, whatever I have explained, how to place the positions the way I have explained you now. Now let us take the first case. Now perpendicular to HP, parallel to VP. Now I'll try to place all the projections on a single straight XY horizontal plane. Okay, what is it? This horizontal is intersection of these two, vertical plane, horizontal plane. This black line is nothing but your XY. Okay, I'll draw it, write it down here. X, this is Y. This XY, I'm going to lay it here. So what happens then? This top half going to be vertical plane, and when I rotate this horizontal plane 90 degrees clockwise, it will come down. This is the position. This is horizontal plane, this is vertical plane. Because when the horizontal plane maintains 90 degrees with the vertical, this position can't be drawn on a flat surface. That is the reason we are rotating horizontal plane 90 degrees clockwise always. Then these two projections going to fall on a single vertical. We'll see how. Let us talk about the first position, which is perpendicular to H, parallel to VP. Perpendicular, parallel. If this is the case, I could see the true shape from the front. So maybe somewhere here. The line is here. Okay. As this is a front view, I can call it as A prime, B prime. Okay. Then followed by a projector line. Fine. Then again, when I view from the top, I could see only a point, single point. When I view from the top, I could see this particular point because this point is coinciding with this point. I'll get a feel that this is coinciding with this particular point. I can see only one point, which is, as this is the top view, this is going to fall on horizontal plane. The point is going to fall on horizontal plane. When I rotate the horizontal 90 degrees clockwise, it will come and align with the vertical. So in such case, what happens? If you consider this as your line AB. Now I kept this AB at some offset distance with respect to XY to make you understand. Okay. He'll give you in the question. A line AB is a line AB of 20 mm length or 40 mm length or 80 mm length is placed at a distance of 10 mm above the HP and 12 mm in front of the VP. Maybe this is a question. If that is the question, 10 mm above nothing but this distance is 10. Again, below it is going to be 12 in front. No, if this is 12, the position is going to be somewhere here. Now from the top, A is visible, B is invisible. Keep B in bracket. Invisible. This bracket indicates that particular point B is invisible to the observer. Okay. This indicates that A prime B prime indicates that it is a front view as well as it is visible completely. Fine. This is the indication. Now what is the length of the line? From top to bottom it is going to be 80 mm. Let us have a look at the second position. If this is horizontal and vertical plane, this is your line AB of 80 mm length. Our second condition is a line perpendicular to VP parallel to HP. Perpendicular to VP parallel to HP means from the front view I can't see the true shape of the line which is 80 mm. True length of the line which is 80 mm. So what I do, I'll change my position to the top. When I change my position to the top, what happens? I could see true length. Okay, let us imagine that this particular line AB 80 mm is maintaining 10 mm above distance, 10 mm in front distance, 10 mm above, 10 mm in front, somewhere here. It is not touching any of the planes. In this case, what happens? I could see the true shape from the top. So I need to draw the top view first because true shape is visible from the top. Fine. So I'll draw the top view first, then I'll go with the front view. Have a look. So as both the planes are maintaining an offset distance of 10 mm with respect to that particular line AB of 80 mm length. So what I try to do is I'll just draw simple line here somewhere. Okay. I'll consider this distance as 10 mm, this distance also 10 mm. Then I'll try to draw one locus. This is the right procedure actually. Fine. So where I could see the true shape of the line from the top. So 10 mm away, try to make a point. From here with the help of drafter, draw a straight line of 80 mm, which is, it all depends on the position again. It all depends on the position. If you consider this end, top end as A, bottom end as B. Sorry, this front end as A, back end as B. A, B. Then what happens? This A will come below. This point is where I could see the complete length 80 of that particular line. Clear? Then again what I try to do is I'll try to give dimensioning of that particular distance which is 80 mm even. Now again I'll try to draw a projectile line from here to till it touch the locus. Wherever it intersect with the locus, I'll try to darken with the help of a point. Now what is the name of this particular point? That is more important now, because if this is the position, this is your point A, this end is your point B. Fine. Point A is visible, point B is invisible. In such case what we do, point A prime is visible, B prime keep it in bracket, because B prime, A prime is hiding B prime, so A prime is visible, B prime is invisible. This is the case. So that is the same thing you need to answer here. Fine. Only point is visible from the front view. Clear? This is what? Front view. Fine. Here this is also front view. This will not change because we are dealing with first quadrant. Front view will always be above the XY line, top view below the XY line. Okay. Now again have a look. When I view from the front, this is the front view position. When horizontal plane rotates clockwise 90 degrees, what happens? Position of the observer will also change. Imagine that way. This will also change according to the plane. Then what happens at this particular point? Front view position. Here comes the front view position. This is also same. Front view position. For first quadrant, whether you are dealing with points, lines, planes, solids, front view position will never change. Horizontal plane rotates means front view position will also rotates 90 degrees. Similarly, here is your top view position. When I view from the top, I could see this true length. Similarly, in this case, from the top I could see this point A. Let us go with next assumption, which is when a line is parallel to both the planes HP as well as VP, parallel to both the planes. So you can draw front view first or top view first, because both the ways you could see the true shape. Length of the line is 80 mm. Now you need to think about whether it is placed at some offset distance from the HP, at some offset distance from the VP or not. Okay. Now you need to know the terminology. Coming to the first quadrant, we deal like above, in front. First quadrant, above, in front. 10 mm above, 10 mm in front of VP. 10 mm above HP, 10 mm in front of VP. If that is the case, what I try to do, again already 10 mm given for the second solution, I'll consider same distance. I'll extend the locuses. I'll make a mark of dimension line 10 mm. Now I could see the true length 80 mm. 10 mm away I'll start drawing the line which is of 80. Let us consider this as 80. After drawing that 80, this 80 is your front view. Okay. Maybe this end is A prime, this end is B prime. Complete length is 80 mm. Okay, true shape. Then again take a projector line from top to bottom. Now wherever that projector line meet with the locus, darken that distance. This is your top view. If this is your top view, you need to name it as A, B. Front view is always front view indicated with a prime. Example, A prime, B prime, C prime, so on. If it is X, X prime. If X is the name, X prime is the notation. Similarly, top view is always indicated with simple alphabet A, B, C, D or 1, 2, 3, 4. There won't be any primes. Fine. Now, this will not change. Front view position. Okay. This is your top view, this is your front view. Clear? We'll go with next condition. What is that? Perpendicular is over. Perpendicular to HP, parallel to VP. Perpendicular to VP, parallel to HP. Parallel to both the planes. Now, inclined to HP, parallel to VP. Inclined to HP, parallel to VP. In this case, inclination will be given to you. In this case, inclination will be given to you. Accordingly, try to draw a line of 80 mm with the given inclination. Then try to draw the projector lines. When you draw a projector lines, you will get two intersections. If you join those two intersections, you will get the top view or front view. It all depends whether it is a top view or front view. It all depends on the given inclination, whether the inclination is with respect to HP or VP. And the length is going to be the reduced length. Length will never be a true length when a line is inclined. Okay, so I'll draw that particular inclination. Let us imagine a line AB of 80 mm length which is maintaining 45 degrees inclination with HP and parallel to VP. Remember, 45 degrees inclination. Okay, the line may be at some above distance, at some infront distance. Okay. Or it may not have any above distance. It may have only infront distance. The conditions are different. That we'll see when it comes to problems. Okay. Now we are dealing with only a concept of lines. Fine. Inclined 45 degrees to HP, parallel to VP. Maintaining an offset distance of above distance of 10 mm, infront distance of 10 mm. Now if that is the case, how to draw? Again I'll draw one XY line. Okay. Now we know angle. There is a line 80 mm, AB line of 80 mm. Theta is given which is 45 degrees. Length we know, true length is given. Only two diameters we have. And above distance, above HP 10 mm given and in front VP 10 mm is given. Okay, for our understanding, I'll take these arrowheads above. If it is above, again, if it is above, give a simple arrowhead. Below, simple below. In front, something like this. Behind, backwards. Okay, for our understanding. Fine. If that is the case, now you have a look at the given parameters or dimensions in the question. If this is the case, 10 mm above and 10 mm below. What I try to do is, I'll try to make a mark of 10. Okay. From here, let us consider this as 10 mm above and 10 mm below. Then draw one locus above and below. Fine. At 10 away from the dimension line, I'll make a mark. Now the line is making inclination of 45 degrees with the HP. So the true length is going to fall on VP. True length of the line is going to fall on VP. If that is the case, so it is coming, the line coming above the XY line. Above the XY line. So here above the XY line, and to draw a line making inclination of 45 degrees. Now with the help of protractor, measure 45 degrees inclination, make a mark, and with respect to the starting point and the inclination line, draw 80 degrees line. Sorry, 80 mm length line. 80 mm length. Afterwards, if this is 80, this end, as this is a front view, we call it as A prime, B prime. Okay. Now draw a projector line normal. Stop wherever it meet with the locus. Now darken those two ends. Fine. Now you can mark it as this is the top view, you can name it as A, B. Ultimate projection you need to darken. Front view projection, top view projection. Other lines you can draw with 2H pencil, but these two need to be drawn with HB pencil. You need to darken it. Now this is the true length, 80 mm. 80 mm whatever we have drawn is true length, but this is, we call it as reduced length. Fine. So whenever a line is inclined, until it is perpendicular, we could see the true length. From the top, point is visible. Only point is visible from the top. Okay. When it is inclined to 10 degrees, you can see a slight length, small length, apparent what we can call. Now, when it is inclined 45 degrees, still you can't see a true length from the top. When it is inclined 60 degrees, still you can't see a true length from the top, unless it is parallel to VP, parallel to HP. Means the line need to rotate 90 degrees to give you the true length. So line is maintaining, when it is maintaining 45 degrees, you can't see the true length from the top. You can see a reduced length, and we don't know what that reduced length distance is. That we need to calculate. Once you take the projectile lines, when you join these two, if you measure this distance from A to B, that is your reduced length. He may ask you to write the reduced length distance also in some cases. Let us go with next condition. If it is inclined to H parallel to VP, this is the case we have drawn already. Same case again in a reverse way. When it is inclined to VP, inclined 45 degrees to VP and parallel to HP, line ATM inclined 45 degrees to VP and parallel to HP, placed at a distance of 10 mm in front of VP, 10 mm above the HP. We are considering this in front above distance constant. So I'll extend the line, let us imagine from here to this end, maybe 10 mm. This is also maintaining 10 mm. Now, whenever the line is inclined to VP, I could see the true shape from the top, not from the front. I could see only the reduced length because it is maintaining some inclination. We don't know what the reduced length is. So now we need to consider only the top view first. If top view is considered, top view will always come below the XY line. So 10 mm, make a mark and draw whatever the inclination given. From this horizontal, measure the angle theta again. Theta is again 45 degrees given. From here, from the horizontal, make a mark of 45. Draw length line. As this is your top view, how to name it as A, B. Take the projectors onto the locus. Wherever intersect, try to join them both. Now, if this is A, top view, this becomes A prime. If this is B, this becomes B prime. Now, this we can call it as reduced length. Okay, that we need to measure and we need to write if required. Okay, now this angle is 45 degrees. This is also 45 degrees. When you club these two, it will give you a line inclined to both the planes, which is a tricky question in case of projection of lines. Okay. Not a tough job. Only thing is we need to imagine. Have patience, imagine whatever question is given to you in the examination. Try to imagine yourself. Okay. Always try to consider. If you are feeling somewhat tough, try to two planes, horizontal and vertical. Take a pencil or a pen, imagine that this is your line. Based on the question, give the orientation, give the positioning, accordingly think about it. If you practice more and more, no need to use such planes also. Only given data is enough to fulfill your answer. Our next condition is a line inclined to both the planes. That I'll explain you in a separate video lecture to make you understand better. This is about projection of lines. That's all for today. Thank you so much for watching. Subscribe the channel and you can give your comments in the comment box given. Thank you.